times the derivative of the inner. There is another way that this is written. You saw this in the book. Many of you had this written down in your notes, so I wanted to explain it. You'll see the chain rule written as such. dy over dx equals dy over du times du over dx. Now you might say, well, of course it is, because when you multiply this, the du's cancel because it's like that. And yes, that does look correct. However, for reasons which I'm not going to go into and that I'm not totally sure I understand, these dy and du's are not they're not numbers, and so they don't cancel out the way that numbers would. But really, kind of the thing is that it matches that pattern. I'd like to explain to you what is going on with this u business, because we are going to see u used as a function, as a letter used to represent a function, kind of a lot from here on, here and out. So the way we would read this is we would say the derivative of y with respect to x, that's what this means, is or equals the derivative of y with respect to u times the derivative of u with respect to x. If you want to write this down, you can. If you don't, that's okay too. And I want to kind of show you what that means in terms of our friend here, oldie goldie, y equals sine of x squared. Okay? What you could think of this function as is y is equal to sine of u, where u is whatever's inside. U is a function of x. Okay? So I'll put that down. U is a function of x. It's an expression, it's a formula. Okay? So u equals x squared. So if I think of it like this, dy over du, the derivative of y with respect to u, is just cosine u. All I'm doing there is what we did last week, only instead of having an x here, I have a u. It's no big deal. Thinking parallelly over here, so that's really a word, but anyway, if u is equal to x squared, du over dx is equal to 2x. I think we would all agree with that. Then looking at the chain rule says dy over dx is equal to dy over du times du over dx. It's just copying that formula down. And then saying dy over du is cosine u, du over dx is 2x, and cosine u, just doing our substitution here, is cosine of x squared. Now, we are able to handle this very quickly nowadays because we say dy over dx is equal to the outer function derivative, so derivative of sine is cosine with the inside intact, times derivative of the inside, 2x. So we're able to jump from here to here, and we did that using our chain rule and all that good stuff. But I wanted to kind of show you what was going on with this, if you're curious. Any questions? I think both of these are on that memorization chart. Yeah, pull out that memorization chart real quick. I'm not sure. The one for this chapter. The one that has all the derivatives. We haven't yet completely filled it out yet. Yep, there's both notations. You now know 12 and 13.